Okay, so next let's examine how can we actually perform this fine-tuning in an effective way. So there is one issue in fine-tuning, specifically in that's relevant for reinforcement learning, in that deep networks work best well when they are big eventually, right? Specifically if we're using image-based state spaces, then we'll need a big convolutional tower, very deep networks with some fully connected layers. When we fine-tune, we typically want to use a little bit of experience, right, to learn more efficiently with less training data. However, a little bit of experience along with big networks usually tends to cause overfitting. So the question that I want to address next with progressive networks would be, can we somehow fine-tune just a small network but still pre-train a big network, right? And this is the idea behind progressive networks. So a simple idea would be to just limit the fine-tuning only for maybe just the last layer or some portions of the full network. Right, and then you can easily freeze training for the other parameters and just perform policy gradient on a subset of the tunable parameters. However, so this will help us avoid wiping out initialization. So we won't forget, we have a new task, we won't forget the previous task and just overfit for the several samples that we obtained from the new task. So that can help us with this. However, it will result in limited expressiveness, right? So it will allow us to retain all of the previous high-level features that we trained on, we learned. But it might be the case that we need new high-level features just because we have a new task. We need to somehow be able to obtain new high-level features. So a second solution would be to add new layers, maybe a new network in parallel to the old one, and freeze the old network. We'll freeze the old network here in gray. We'll just add more alternative layers. By doing so, we retain all of the previous features, latent features that we learned, but we allow our network to learn new features. Right? Just inflate, although we'll have a bigger network, right? More parameters. And this is indeed the idea behind progressive neural networks. And here are some results for different approaches to construct the progressive networks. So for instance, baseline number one would be just to not freeze anything, that is to pre-train on one network, and then to allow all of the parameters in the old network be tuned. Okay, so that's one baseline, just to see that we can actually gain something from freezing some portions of the network. And by the way, we are using very deep networks because these results are for also used image-based tasks, right? Like the Atari domain, like video games. Another baseline would be to just freeze the bottom layers and just allow the RL to fine-tune only the final layers. But as we said before, this might limit the expressiveness of the system, right? It might have trouble in learning new features. Okay, so just to summarize the fine-tuning approach that we saw for transfer learning, we can just start by trying and hoping for the best. Train our RL agent and then just move it to the new task. Sometimes there is enough variability during training to generalize. Next, we can specifically address the overfitting issue when we transfer between tasks. And we can easily do that by adding a maximum entropy objective, right? We saw that. And finally, we can also define progressive networks, that is, allow the network or change the architecture of the network as we progress to new target tasks. And this allows us to address some overfitting and expressivity problems by constructing the new network, by adding new hidden parameters.